Hey guys, Happy New Year's. Hope you're doing well. It's nice to be able to teach you again in this new year. Anyhow, we're going to start a new lesson today, and it is Chapter 3, Section 4. We're going to learn about something called the constant of proportionality to describe proportional relationships. So you can get your book out, pause the video here, go to page 182 to 184. You might want to grab a calculator, and here we go. Okay, one of the main goals of this lesson is to be able to write an equation for a proportional relationship. All right, so what do these equations look like? Well, they're very simple equations. All right, so you have some variable y, it's equal to k times x. All right, y and x are variables. All right, so they're not going to have numbers for them. They're going to represent unknown quantities that will change throughout the problem. And k is a special number called the constant of proportionality. Okay, now this form only exists if a situation is proportional. And remember, if a situation is proportional, then every y over x, y divided by x, will be the same. You'll get the same value for y divided by x for all sets of data pairs. Okay, so if k equals y over x, all right, once you figure out the value of k, you can simply substitute it to write the equation. All right, so once you find k, replace k, and then you have an equation that looks like y equals kx. All right, so why do we want to write equations? Well, equations are a very powerful thing. Okay, you can represent any possible situation for two quantities with an equation. All right, so for example, here's a proportional equation. D equals 5t. Okay, so here D is for distance. This allows you to find distance given k, which is 5 miles an hour. So that's your speed. Okay, so the k value is the speed in this equation for any given time. So like say if I were to go for 2 hours, then my distance would be 10 miles because 5 times 2 is 10. Okay, so 5t here means 5 times t. All right, so just for clarification, y equals kx means y equals some value k multiplied by x. All right, and you don't always have to use y and x. You could pick other letters that are more appropriate for your situation like d and t. All right, so let's look at the problems on page 182 here, and let me pull it up. You should see example 1 dealing with a sponge. Okay, and the sponge has a constant flow of water through its body. We are writing an equation that represents the proportional relationship between the time and the amount of water filtered. Okay, so in a proportional relationship, time is almost always your x variable, and whatever else, the amount of water, here it's liters, is going to be the y variable. All right, so let me play the video here.
The constant of proportionality is the constant multiple that relates proportional quantities x and y. It is the value of the ratio y over x and is represented by k. Let's make a table to find the constant of proportionality. We'll need to track time, hours, and the amount of water filtered, liters, to determine the rate, liters per hour, the sponge filters water. Which quantity should be y and which should be x?
I already said that, but that's okay. What do you guys think? X is hours.
X is the independent variable. Y is the dependent variable. The liters of water, y, that flow through the sponge depend on the number of hours, x, that have passed. So, the rate, liters per hour, is y over x. In 10 hours, the sponge filtered 8 liters of water. The ratio y to x is 8 to 10, so the unit rate is 8/10 liter per hour. In 15 hours, the sponge filtered 12 liters of water. That's a ratio of 12 to 15, and a unit rate of 8/10 liter per hour. The ratio is constant, so the constant of proportionality, k, is 8/10.
So that is why they call it a constant of proportionality, because it's constant. It will be the same for every y and x value, okay? And to get 8/10 there, just use your calculator and take 12 divided by 15, or 8 divided by 10, which you should know is 8/10 anyways. All right. So now what's our
You
equation
can use the
here?
value of k to write an equation that represents a proportional relationship. Recall that the constant of proportionality is equal to the ratio of y to x. Multiply each side of the equation by x. Rewrite the equation. Use the equation to represent the relationship between time and the amount of water filtered. Which variable in the equation has a value of 8/10?
Select your answer.
That's the constant of proportionality, k.
Substitute 8/10 for k. Now you know how to write an equation that represents a proportional relationship.
Very good. All right, so they showed you here how you get the equation y equals kx, okay? But you don't have to do this every single time because you know the equation should look like y equals kx. All right, now I want you guys to go ahead and try the try it problem, which you will see coming up here. So go ahead and pause the video and work it out here, then I'll go over it. All right, so Maria is making some fruit punch. All right, so let's see if she has a proportional relationship. All right, well, let's see. If we take, remember, we want to figure out the k value, which is called the constant of proportionality, by taking y over x. So it would be 8 over 5 here, and down below it's 16 over 10. And if you reduce 16 over 10, it's 8 over 5. So that really shows you that, you know, the constant, this is proportional because you got the same value for k. All right, now what is the decimal equivalent of 8 over 5? Well, just put it in your calculator. 8 divided by 5. Always put the top number in first. So the constant of proportionality, k, is 1.6. Okay, so remember that's the value for k. So the equation that you could write for this situation is y equals 1.6x. All right. Here's a little convince me question. How does the equation change if we switch grape juice and apple juice, essentially, okay? So it really doesn't matter which one is x and which one is y here. So this situation, you could switch grape juice and apple juice up. And how would it change? Well, the k value would change, okay? K, instead of being 8 over 5, would now be 5 over 8, okay? And that would give you a different decimal. Or you could just use the fraction, really. So your equation would be y equals 5/8 x. But in this situation, you would have x be representing grape juice and y be representing apple juice. All right, so anyhow, that's the convince me question. But this is the equation that you're actually trying to find here for this particular table here. Remember, it's always y over x, and y here is grape juice. All right, let's look at the next problem. Example 2. Another area where we can use proportional relationships is in conversions here, okay? So 1 inch is 2.54 centimeters. How many centimeters long is an 18-inch roller? So if we had an equation that would be useful for figuring this out, well, if there's a relationship between units, that is basically the k value. 1 inch is 2.54 centimeters, okay? So k, in this particular one, let me clear this out. Okay, so x is the inches. So if you put in inches here, then the amount of centimeters is going to be 2.54 times the amount of inches. Okay, so that's the y value. All right, so in essence, then we have 2.54 for your value of k, because it would be 2.54 over 1. All right, so the equation that we can use to convert from inches to centimeters is y equals 2.54 times x. Okay, so we don't put the times sign because it's understood here, but 2.54x. All right, so substitute k, that's what we just did. But here for this particular situation, k is equal to 18. Okay, so we can figure out how many centimeters that would be. Okay, because there's going to be more centimeters than inches. And my marker just got really, really chubby there. Okay, so let's try this again. Y, got really big again. So y equals 2.54. And then to show that you substitute, it's a good habit to use parentheses when you're substituting numbers. So please use parentheses there. So 2.5418, and that means you're multiplying here. and just for sake of time, you can use a calculator, and then you would have y being equal to 45.72 centimeters. Okay, make sure you label your answer here so we know we're talking about what we found, which is centimeters. All right, let's check out the next try it problem. I'll let you guys try it and pause the video as you're doing it here. All right, so we got a florist selling a dozen roses for $35.40. All right, so this one's a little bit tricky because it's not really clear what the K value is. But you have a dozen roses, so that's 12 roses for $35.40, okay? So they're telling you X is roses and Y is the cost. All right, so you're getting 12 for $35.40. So this is proportional because she sells one rose for the same cost. Okay, so we can figure out K by taking the cost, which is $35.40, divided by 12, and then that's your K value. All right, and so we would get $2.95. Okay, and then with that we could write an equation to figure out the cost Y for X amount of roses. So you're basically taking how many roses you purchase and you multiply them by $2.95. So how much would 18 roses cost? Once again, substitute. Now, what are we substituting for, X or Y? Well, the cost is Y, the roses are X, so we're putting the number in for X, and then you just multiply it, and you can use the calculator again. So the cost would be $53.10 for that amount of roses. All right, let's look at example 3 here. Okay. So, can we represent this with an equation y equals kx? Well, maybe, maybe not. Admission is $20. It's $5 per ride here. Okay, so first ride will cost you $25 because you have to pay for the admission, which is $20 plus $5 per ride. Second ride would be $30, third would be $35. Now, how do we know if this is proportional or not? Well, you got to figure out the k value for each one of these x, y pairs here to see if it's the same. Well, the first one is 25 to 1, so your k value would be 25. However, this second pair here, if you take 30 to 2, you would get 15. So there really is no true k, okay? Because the k is different. It's not a constant. So therefore, you cannot make a proportional relationship out of this particular table. All right? What about this table here? Okay? Oh, look. Okay, so that's just showing you that all the k's are different, so it's not proportional, and it's explaining it. All right. Now, here is a try-it problem. You're comparing two balloons, okay? And see if you can write an equation out of it. Which situation? Maybe both, maybe neither. Pause the video, find it out. All right. So, balloon A, nope, there is no constant k value, so it's not proportional. You can't write an equation y equals kx. Okay, you get 9 for the first pair of data, you get 6.5 for the second pair of data values. Balloon B, however, cha-ching, guess what? You can write a constant of proportionality equation here. You get k equals 4 for each one of them. Okay, 8 over 2 is 4, 12 over 3 is 4, 4 over 1 is 4. Okay, so you would want to, if you were showing your work, you would want to write out the ratios for each and show that they're all equal to 4. And so what equation would that be for balloon B? Well, we can model its height by writing the equation y equals 4 times x. Or if you don't want to use y and x, you could say the height is equal to 4s, where s is equal to seconds. So either one of these would be a good equation. All right, so hopefully this helps. Now you guys are going to try some more problems on Math Excel. So have a great day, guys, and we'll go over them tomorrow. So try your best, and talk to you soon. Bye-bye.